On October 3, 2025, an object from another star system is going to get terrifyingly close to Mars, and for the first time in history, every single one of our rovers and orbiters faces a real off-world disaster test. But here's the twist. While this is happening, Earth will be completely blind. We won't be able to see a thing. Scientists initially expected a harmless flyby from this interstellar comet named 32 Atlas. Instead, they discovered a cosmic monster pulsing with carbon dioxide, exploding in brightness, and breaking every rule we thought we knew about how comets behave. Official mission forecasts talk about observation opportunities, but they don't mention the communications blackout, the comet's erratic power surges, or what happens if Mars's orbiters are suddenly cut off from us. So what could 32 Atlas really do to Mars in a worst-case scenario? The scariest possibility isn't necessarily a direct impact. It's what could happen in the hours when no one is watching. October 3, 2025 isn't just another date on a mission calendar. It marks the first time an object from another star system will pass through the Martian neighborhood while a full fleet of our technology is active. We have no rehearsal for this. There is no precedent. Every probe circling Mars, every robot crawling its surface, is now part of a live experiment in planetary defense, whether we like it or not. The numbers alone are staggering. 32 Atlas will pass within about 30 million kilometers of Mars. That might sound like a lot, but in astronomical terms, it's a hair's breadth, especially for an object hurtling through space at nearly 68 kilometers per second. Mars has never faced an interstellar visitor this close, let alone with billions of dollars worth of hardware in the potential line of fire. What makes this date even more critical is the blackout. As Atlas closes in, Mars will slip behind the sun from our perspective. For over a month, our ground controllers will be flying blind, unable to send commands or intervene if something goes wrong. The stakes are very real, measured in decades of exploration and the survival of humanity's first planetary network beyond Earth. October 3rd is the day the abstract threat of interstellar objects becomes a concrete, irreversible test. Atlas, the third confirmed interstellar object to visit our solar system, refuses to play by the rules. At first glance, it looks like a dirty snowball on a one-way trip out of our solar system, barreling past Mars at a speed that would let it cross the United States in under a minute. But the closer scientists look, the stranger it gets. Its closest approach, about 30 million kilometers from Mars, puts it squarely in the neighborhood, close enough for our orbiters to capture details our best telescopes on Earth will miss. But what really stands out isn't just its speed or path, it's the chemistry. Atlas has a coma, a fuzzy envelope around it, that's dominated by carbon dioxide, not water vapor like most comets. The ratio of CO2 is so high, it's forcing researchers to completely rethink what interstellar chemistry can even look like. And then there are the brightness surges, erratic, sometimes violent outbursts that spike and fade without any warning. Its jets of gas shoot off at odd angles, and the entire comet seems to pulse with energy, as if something inside is fighting to break free. For planetary scientists, Atlas is less a visitor and more a wild card. Its unpredictable behavior, its alien chemistry, and its incredible speed all raise the same uneasy question: what else is hiding inside this thing? And how will Mars respond when it passes through the crosshairs? From October 1st to November 9th, 2025, both Mars and 32 Atlas will vanish into a solar blind spot. For mission controllers, that means over a month of radio silence. Every signal will have to pass through the sun's blinding interference. No ground telescope, no deep space antenna, not even the James Webb or Hubble can track the comet's closest approach. The only eyes left are the orbiters already at Mars: MAVEN, MRO, TGO, Mars Express, and Tianwen-1. These spacecraft will become the sole witnesses trying to relay fragments of data across a communications gap that could swallow anything from a minor outburst to a catastrophic event. This blackout isn't just inconvenient. It's a critical vulnerability. If Atlas suddenly fragments, brightens, or does something we've never seen before, we on Earth won't know about it in real time. Engineers have rehearsed contingency plans for years, but as this window opens, every scenario becomes a roll of the dice. In the control rooms, teams are bracing for the possibility that the most important discoveries or disasters will happen completely unobserved, with only the faintest electronic whispers making it through the static. Imagine a city-sized object from another star system barreling past Mars and suddenly coming apart at interplanetary speeds. That's the scenario keeping analysts at NASA and the European Space Agency up at night. When a comet like 3-2 Atlas fragments near a planet, it doesn't just disappear. It seeds the orbital neighborhood with a swarm of debris that can persist for years, even decades. Each fragment, from boulder-sized chunks to clouds of fine dust, follows its own deadly path. Some might graze the Martian atmosphere, while others could loop into a temporary orbit around the planet. The result isn't a single event, but the creation of a shifting, invisible minefield. Models show that even a moderate breakup could scatter thousands of fragments. Some could get snagged by Mars's gravity, circling the planet in unstable orbits before spiraling down or being flung away. Others could drift into crossing paths with Mars's fragile moons, Phobos and Deimos, or linger in the exact orbital corridor our spacecraft use. Each pass raises the odds of a collision, not just now, but for every future mission trying to navigate this gauntlet. The risk isn't limited to a single season. These debris clouds can evolve, fragment further, and spawn new hazards with every Martian year. The European Space Agency's Coordination Center warns that the worst case isn't a dramatic impact, but a slow-motion cascade Kessler syndrome-like belt of junk that could one day turn Mars' orbit from a gateway to a graveyard. The legacy of this interstellar visitor may be measured not in craters, but in the invisible, persistent threat of shrapnel drifting through the red planet's skies. Now, let's consider the nightmare scenario, a direct hit. A city block-sized fragment from 3-2 Atlas, striking Mars at 68 kilometers per second, would unleash more energy than the world's entire nuclear arsenal combined. The numbers are hard to grasp. A 1-kilometer nucleus traveling at that velocity carries enough kinetic punch to excavate a crater up to 35 kilometers wide and impact scar visible from orbit for millions of years. The shockwave would vaporize rock, flash fry the surface, and hurl billions of tons of dust into the thin Martian air. For the rovers on the ground, Perseverance, Curiosity, and Zhurong, there would be no shelter. Dust would rain down in a choking curtain, blanketing solar panels, clogging filters, and plunging the planet into darkness. Even the nuclear-powered rovers would struggle as the sky dims and temperatures plummet. But the devastation wouldn't stop at ground zero. The explosion would inject fine dust high into the atmosphere, scattering sunlight and triggering a planet-wide dimming. For months, maybe years, Mars could experience a kind of artificial winter, with temperatures falling and sunlight cut by half, shrouding the surface in a copper-colored haze. Our orbiters flying overhead would face their own crisis. The electromagnetic pulse from the impact, amplified by swirling charged dust, could scramble their sensors, trip safety systems, and knock out communications. Engineers on Earth, already blind from the solar conjunction, might not know for days if their spacecraft even survived. In the control rooms, every lost signal would feel like a gut punch, a reminder that Mars is now a testbed for the unthinkable. But the most subtle threat might be the most dangerous. Invisible threats don't leave craters, but they can scramble a planet's entire electrical nervous system. As 3-2 Atlas sweeps past Mars, it will drag a vast cloud of ionized gas and dust, a plasma tail threaded with energy straight through the Martian neighborhood. Mars isn't shielded like Earth. Its thin atmosphere and patchy magnetic fields make it especially vulnerable to electromagnetic disturbances. Scientists who track space weather know what happens when a comet's plasma tail brushes a planet. In 2014, when Comet Sighting Spring passed by, it triggered auroras across Mars' brief, ghostly curtains of ultraviolet light far brighter than anything seen before. This time, the encounter will be closer and the comet is far more active. A powerful plasma interaction could overload the electrical systems of our orbiters, causing short circuits or phantom commands. On the surface, the rover's sensitive instruments could be disrupted. The very environment could turn against our robotic explorers in ways we can't fully predict. This encounter is more than just an astronomical curiosity. It's a dress rehearsal for planetary defense, a live-fire drill we never asked for. Whatever happens on October 3, 2025, our understanding of the solar system and our place in it will be changed forever. We'll be watching, or at least trying to. Thanks for watching. If you found this cosmic story as fascinating as we do, don't forget to like, subscribe, and hit the notification bell so you don't miss our updates on this and other amazing events in our universe.